A variation, okay, is a relationship between two or more quantities. Okay, specifically when we talk about direct variation, okay, it's a relationship between two things, and the ratio of these two things, okay, is always a constant. For example, when I multiply the x by 2 times, your y would also double. So if your x triples, same thing will happen to y, etc. 4 times, 4 times. Okay, so this is exactly what it means by direct variation. And how do we mathematically express this? Okay, by using this symbol. Whenever you see this, this means x and y have a direct variation. And because they always remain the same ratio, that ratio would be what we call the variation constant, and is usually expressed as the letter k. So for part A, how do we find that variation constant? As you can see, y goes first. Okay, so you take each y divided by x, and you would expect to get the same constant all the time. So from the table, variation constant equals to 4/3. Now if we want to plot the graph of y against x, basically you use these coordinates. So here you go. And you would expect that slope to be 4/3 because the equation would simply be this. And for part C, when y equals to 6, find the value of x graphically. So here you go. This is the answer. When y equals to 6, it's right here. So you draw this dotted line and back down here. So from the graph, when y equals to 6, x equals to 4.5. So that was actually all warm up to get to know better about the concepts. Here's the real thing. So it's given that y and this whole thing have a direct variation relationship. X has to be greater than 0. So when x equals to 5, y equals to 72. So some initial numbers for us to substitute and find the k, the constant, and find the value of x when y equals to this. So first step, you always need to set up the equation. How? Because this and this whole thing have a direct variation relationship. So y over this thing would be a constant, which is k. Okay, so that's how we express it all the time. Okay, so y equals to k times this, always. And we must say k is a non-zero constant, because if k is 0, okay, this whole thing doesn't really make sense. If this is 0, then that's meaningless. The next step is you use these initial numbers and substitute into x and y. This is to find the value of k. So 72 equals to k times 5 minus 1 whole square. And you got k equals to 9/2. Now you've got the entire equation. So this was the missing piece. Okay, now you've got it. So we have the equation. Then we could substitute whatever we want to find. So here's the complete equation. And we want to find when y equals to this, what is x, right? So we put this into y and we solve for x. Now here's a quadratic. So you may have two answers, but because x must be positive, so this is rejected. So here's the answer. And so here, this part is the last step. You take the whatever it's asking you for, you put this back into the equation to solve your answer. So for this question, there's another method actually. Because there's a constant ratio for direct variation, then we could actually put them side by side as a ratio, and we could solve the last number here, right? y1 over this whole thing in terms of x1 must always equal to y2 over this thing, but in terms of the x that we wanted. So we just substitute, right? So you put this one in here, which matches with the y1. x1 with y1 and x2 with y2. So here's the x2 and here's the y2. They always matches. And you still end up with pretty much the same quadratic. And of course, you reject the same thing, and you answer your question at the end. When y equals to 648, x equals to 13.